born in India and grew up there, and now I'm teaching at Selwyn College, Auckland. And I'm very passionate about mathematics, especially after I started to work on Vedic maths as part of a Royal Society fellowship, and this led to a PhD. The decimal numeration system and the early algebraic ideas have come from India. So I was very interested to investigate Indian history in order to understand how the decimal system came about. And I wanted to see what are the ideas that we can use for teaching and learning. And I'm very grateful for all the awards that I got, because I came to know more about India living in New Zealand. So I'm very happy, very grateful for the Royal Society Award and the Study Award and the Kalman Award. I would like to first acknowledge my gurus and mentors. I was I was introduced to Vedic maths, in fact, by Bill Barton, and he said, "Why don't you do that as a topic for the Royal Society Fellowship and see what comes out of it for classroom and the generalizations that one can make." Basically, Vedic mathematics is some ancient multiplication methods. And for my PhD, I was supervised by Mike Thomas from the University of Auckland as well, and Professor Andy Begg at AUT. And I was also mentored by Professor MS Rangachari, Srinivasan, and Dr. George Joseph from the University of Manchester. Many of you may know him. George Joseph, he wrote the very famous Crest of the Peacock, Non-European Roots of Mathematics, a very famous book. What are the ways of incorporating history? One is where you have a direct approach, investigation of different number systems, and then multiplication methods. Then you can investigate the life and work of mathematicians from the past, the types of problems that are solved, patterns in different cultures, what is the maths involved in monuments. There's no limit. And it's all of them are low flow and high ceiling kind of problems. There is also the indirect approach, which is teachers' knowledge of history that informs teaching sequences. For example, we are all aware that for many students, operations on zero and negative numbers is quite hard. So our knowledge of history and the length of time it took for mathematicians to come to grips with it helps us understand how difficult it is for students, and accordingly we will have the scaffolding in the teaching sequences. And the third method is the mix of approaches, looking at historical evolution, and also then you arrange your teaching in the modern context, but you are aware of some amount of the evolution, and then you prepare your lessons accordingly. But for this talk, I'm mainly going to look at the first three, looking at different number systems, a few multiplication methods, and mathematicians from the past. Those are the first three that we will look at. What are the reasons for using history? There was a study group in ICME, and they came up with history and mathematics education, documented a lot of the ideas from different educators and researchers, and what they some of the points that they mention is increases motivation in learning, humanizes mathematics, makes mathematics less frightening for students, and presents it as a global endeavor. And it locates mathematics in a cultural context, because mainly all the mathematics that we study today had cultural roots. And students derive comfort from realizing that they are not the only ones with problems, because mathematicians have come across, false paths and dead ends, and they faced lots of challenges, and they realize, okay, all these formulae and stuff have not dropped out of the big blue sky. It's hard work of many mathematicians, and it provides lots of opportunities for investigation. Other reasons: helps to order the presentation of topics in our curriculum, helps develop a multicultural approach. Auckland and New Zealand is very multicultural, and there are about 72 different cultures in my classroom. So I wanted to use multicultural approaches as much as possible. Past difficulties are a good indication of present pitfalls. So if there have been difficulties in the past, it's quite likely that students also face the same difficulties. And knowledge of that helps us to, helps us to prepare our teaching and learning. Exploring history helps us to sustain our interest and excitement in the subject, provides opportunities for cross-curricular work with other teachers and subjects. And but there are also some disadvantages. Some of the disadvantages that are listed by teachers is actually finding the time to prepare for teaching and learning, and finding the appropriate resources. And sometimes the resources they feel are not easily available, but they are increasingly becoming available, as we will see at some of the resources that are available in the market. So we will start with that one example of a direct approach, and that is, looking at different number systems of the world. I've put 3 or 4 examples, and we can have a look at that. This is the kind of task that you can set students. And all of these have, the ones that I'm going to show has come from this book. It's such a good resource. I've just given these examples, and all students find it fun to translate from an Egyptian system. This is the Egyptian system, and translating it to our numerals, and the other way around as well. And then, we can encourage students to think about other issues. Is there a place value here? Is there a zero? What is the story behind some of the symbols that they have used? Things like that. And this is going up to 1 million, sorry. The symbols go up to 1 million. So how did they build the pyramids with these, with this knowledge of symbols? Or if they needed something bigger, what would they have done? And gives students an opportunity to create more symbols. So there are lots of opportunities for critical and creative thinking. This is the Chinese rod numerals, how they were used. This is from Claudia Zaslavsky's book. And this is how units and hundreds were written, but tens and thousands horizontally. This was written vertically. Then we can get students to write from Chinese rod numerals to the current numerals as is shown. And what the Chinese did was they left an empty space for 0. So lots of opportunities for discussion here. The next one is, this is a Mayan numeration system. The Mayans, like the Indians, were into astronomy, and as also in the Babylonian number system. And so they dealt with very large numbers, and this was a base 20 place value system. And students can translate from one to the other, think about the symbols used, and compare one with the one enumeration system with another. Here's the Greek numeration system. This was a multiplicative system, and they had symbols for 1 to 10, and then also 10, 20, 30, etc., and also from 100 to 900. So there was a lot of symbols to remember, but theirs was a multiplicative, as opposed to a Roman one, which is additive. So these are some of the things that we can discuss with the students. The Maori numbers, one opportunity, given that we have histories in the curriculum, and ours is a bicultural curriculum as well as a bicultural country. We look into Maori enumeration system as well. So if we provide students with some basics, we know, I didn't know Kore was 0, so I learned that. And 100 is Ro, and 1,000 is Mano, and 1 million is Miriano. And then we can carry on from that, and 1 billion is Biriano and Tiriano, and so on. So there are some examples, and students can convert from decimal numbers to right numbers in Maori. And I'll provide the resources, I'll provide this worksheet and also the answers, so it can be useful for you to check your students' work and talk about it. So with investigating different number systems, the advantage is it's low flow, high ceiling kind of rich task. Students can convert numbers, but other students can try and answer some questions. What is the base of this number system? And what is the base of the Babylonian numeral system? These are just examples of some questions that you could ask. And I'm in the resources, I'll be providing you with some other questions that you can ask as well. And can you think of the common units of measurement that could be used in base 60 in Babylonia, or we still use base 60 with, and what is a sub base in Babylonian system, and which number system is the Maori enumeration closest to? So lots of things. They can compare different numeration systems, like the Roman and the Maori, and they can compare with the current numeration system. Lots and lots of opportunities, and students can create their own enumeration system as well. Then it gets them thinking, what are the components of our decimal place value system? The next activity that is very useful is looking at different multiplication methods. And I've given 3 examples, and this is from NZ Maths and also from the Figure It Out book. This is the Egyptian multiplication. So their method was to double and half. So for instance, and that I think that strategy was also part of the numeracy project earlier. So if you want to multiply 12 times 24, you can start with 24, one of the numbers, and then you keep doubling it. And then you keep count of how many multiples of 24 you have. So 24, that's 1, then 48, that's 2, 96, that's 4, because you're doubling it. And then finally, you want to see what are the numbers here that add up to 12. So you can go 8 plus 4 is 12. So 12 lots of 24. And adding 192 and 96 gives you the answer of 288. So there are varieties of methods. You can start the other end as well, but students will come to know which is the most efficient. Moving on, this was this lattice or Gelosia multiplication was done by Italian mathematicians and also some of the Indian mathematicians, and that was translated into Arabic and then Latin by Al-Khwarizmi. And in this, this is to do with multiplying 987 times 961. You set out the grid like this, that is 987, and this is 961 at this end, and you multiply, and then you go 9 times 9, sorry, 9 times 9, and that is 81. Put the 8 and 1, and similarly do the other grids, and then add along the diagonals, and that will give you the answer, which is 948,507 over here. So many kids like to do this because it's visual and they can clearly see what they're adding, and the diagonal lines help them, it helps them to know what they have to add. So that is the Gelosia multiplication. And now we come to the Vedic multiplication from India. And this is one of the master's papers that I did, and Bill Barton supervised me in this, and later on Mike Thomas as well. And quite interesting because it seems like magic, especially when you say it out to the students and they are just wondering how it goes and how it works. And then when they try to find the algebraic explanation behind it, they see that it's a generalization. So just to show you a few examples. Okay, I'll start with this one. Here we have 102 multiplied by 108, and this is how you set it out. You have base 100, you set out the numbers here, 102 and 108, and this is a surplus, 2 above 100, and this is 8 above 100, so you set it out as +2 and +8. And then what you need to do is to multiply 2 and 8, and you get 16. And this is, you get it by adding 102 plus 8, and you get 110, or 108 and 102. So that is the diagonal thing there. So the answer is 11,016, and that is 102 times 108. Likewise, this is another example similar to that. And what if, these are all, I've taken the example with numbers close to 100. There are other methods as well, but we are just sticking to this Nicola method for this. These are also numbers close to 100. So 96 times 93. So here it's the base is again 100. Set out 96 and 93 this way, but it is less than 100. So deficiency is -4, and here for 93 is -7. So again, you multiply this, and it's a good exercise when you come across integers and you say -7 times -4, that's +28. And here you add across 96 added on to -7 is 89, or 93 added on to -4 is 89. And the answer is 8,928. And here, this is a mixture. How do you do 102 times 96? You set it out again like this, +2. This is a surplus, but a 96 a deficiency. And then you go -4 times 2 is -8. And 102 added on to -4, or 102 minus 4 is 98. What we want students to understand here is that what they see here, this is when they multiply something, numbers close to 100, two numbers, what they are expecting to get, an estimation would be close to 10,000. So this number, what they have got here is 98 hundreds. So there are only two places left for them. So what they are doing here is it's 98 hundreds minus 8, and they get 9,792, and that's the answer. Likewise, this is 89 hundreds, and then 28 add to that. So that is the thing, we want to embed place value, and it's a good activity to embed place value as well. Now, the algebraic explanation for this is this. If you take this example, what's happening when it's 103 times 104? We don't have to show this to the students at the start, but to encourage them, if they're struggling, we can say, how would you multiply 100 plus 3 and 100 plus 4? They can either set it out one beneath the other and multiply, or this is what they will get. But what they are trying to see is how what is a common factor here between this, and this, and that is 100 brackets 100 plus 3 plus 4. So the distributive law is applied here. It's a good opportunity for students to practice that. and that is 100 times 107. So we have 107 hundreds here, plus 12, and so therefore it's 10,712. And the algebra, of course, if you have x as any base, we can take this to 1,000, 10,000, we can generalize it. And that's what we want to do, depending on the levels of the students, generalize the methods. So x can be any base close to 1,000, 10,000, and so on. And x plus a, x plus b, they multiply this. I apologize for the multiplication and the x sign. It looks similar, but yeah, I hope this is visible. So x times x plus a plus b plus a. So this is your x plus a, and this is the b. So that is the x plus a plus b, and there are hundreds of that, whatever the base, and then plus a times b, which is these numbers at the end. Students really get excited by this. They want to know, especially if you haven't given them a worksheet, but you do it in class. Now, you asked me a question about two numbers multiplied by 100, and each one is coming up with a question. They get very excited when you do this in your head or just on your palm, and then you give out the answer. They really, oh, how did you do that? And the magic is what motivates them to find out more, and gets them to understand. They're motivated and interested to understand this deeply. So that is the multiplication method. And the next is the activity which has worked really well is to investigate the life and work of a mathematician. So with this activity, I gave them a brief, and I will share that brief with you as part of the resources. It's a collaborative project on the history of maths. The brief basically said to them to get themselves into groups of 2 or 3 or 4, and then they have to choose a mathematician that they would like to investigate from any culture and any time period. And I encourage them to choose, mathematicians from different cultures and not just from Europe. And they had to, I stole this idea from Robin Avril. Some of us wrote a chapter in her book, Middle School Mathematics and Practice. And here, one of the things that we were asked to do by Robin is to write the subheadings and headings in Maori headings and subheadings. And what I wanted to ask the students to do, was to write 1 or 2 things about the mathematics. Some of the mathematics was beyond them, but it was not actually about the mathematics, but who or what inspired the mathematicians. Despite the challenges that many of them faced, what made them persevere? Because that's what we want students to do, to be motivated, to be interested. And even if they find the going hard, we want them to persevere and have a growth mindset, like what Joe Bowler's, Joe Bowler has said in YouTube, website. So despite the challenges they faced, how come they persevered? And they had so many false paths, whether in their family or within their work. Some of them faced discriminations. How did they persevere? That's what we wanted the students to, that's what I wanted the students to find out. And also, in the brief that I gave them, also what was the contribution and what is the effect of the mathematician on people's lives, and what was the effect of doing this project for the students. So these are some things that they reflected on. So I'll give you some examples of students' work. I'm not putting up all the slides, just a few slides of what the students thought and said. So one of them, one group talked about their project was, they chose Katherine Johnson. She's an African American, was chosen by NASA to work on computers. She the students did a lot of work. This is just one slide. And here is the English heading and Maori heading. And what they found out was she made last minute calculations that a computer got wrong to save the astronauts and that first sent the US rocket in space. And this has come up as a movie, Hidden Figures. And it was at that time that the movie came out, and the students were very interested to talk about her because there were not many women mathematicians who were astronauts who were doing those calculations, and especially African American. So they also said he faced challenges, and she had to walk a kilometer before she had to get to the bathroom, and things like that. There were little things that they said, and she said they were surprised, and they learned that she persevered, despite being made redundant. She persevered, and her last-minute calculations saved some of the astronauts' life. Katherine Johnson was motivated, this is what the students found out, because she wanted to change the opportunities for both Black people and women. She faced a lot of discrimination from her male colleagues as well. So these are some of the, some of the features that they found out. There were other interesting topics and mathematicians that they found out about, but I wanted to encourage them to find out about New Zealand mathematicians as well. And one of them, they chose Alexander Edkin, and he was born in 1895. He was very good at calculations, and this is from one of the group slides. One of New Zealand's greatest mathematicians. He performed well with difficult calculations, and this is what they said. They quoted from Alexander Edkin, "Only at the age of 15 did I feel that I might develop a real power. And for some years about that time, without telling anyone, I practiced mental calculation from memory like a Brahmin yogi, a little extra here, a little extra there, until gradually what had been difficult at first became easier and easier." So the students told me, okay, this person, it's not that he knew everything right from the start. He practiced and practiced, and that's how he mastered something. So that gave them a message. The more you persevere and practice, you will master it. Then another student did work on Euphemia Lofton Haynes. She was the first African American to get a PhD in mathematics, and she taught for many years. She was first a school teacher in Washington, D.C. public schools. Her inspiration came from her mother and the church, and then she was hardworking and persevered, just like her parents did, and had her goals in sight. This is what the group found out. She never forgot her roots. And then she didn't stop with that. She was involved in creating opportunities in a community for very poor students. So there were a lot of students who came up to me afterwards, and they gave me some feedback on what they had learned. And I'm just going to show you that in the next slide. So they said all these mathematicians have persevered. I think I will try harder at my mathematics, even if I find it hard. I learned a lot of mathematicians from the past. I thought it was good to be able to choose our own group, and being able to present helped me to be more confident in speaking about a topic. This also improved my teamwork skills. These are the comments from students. I just put in some of them. Variety to learn from and get to see other people's views. Group work and working on the history of math is a good way to learn maths. I think all the presentations were good, but taught me something about the history of maths. It was good to learn about mathematicians. And it was great. Everyone could contribute. And one of the students, I haven't got that slide here, did work on Erdos, the Hungarian mathematician, and he said, I was so fascinated by this mathematician and the work he did. Miss, I'm going to explore more about Erdos's numbers, which is great, which is what we want them to do. So these were the comments. One other thing, because today we had Rachel Cunliffe talk about data and statistics and questions in census at school, I thought I won't go into it because I'm conscious of the time, but Florence Nightingale collected data during the Crimean War, and she used the polar diagrams to create the representation of the data. And this here, the blue is the preventable diseases and people who died in the army through wounds. That's the pink one, and the gray-black one is all other causes. And this is how she represented it. I will share this link as well in the resources, and there is some bit of background about the Crimean War and what Florence Nightingale did, in terms of collecting the data, and because she used the data to help other people who were dying and wondering how it can be prevented. So these are some of the things that you can learn from looking at history. So they are all the sort of the people and the situations sort of come alive. These are some of the present resources from this presentation that I will be sharing: the Vedic maths worksheets, Maori enumeration and answers, and critical and creative thinking questions, and you can add on to it. It's just a few, and the brief that I gave the students. And I also have numeration systems from other cultures, a few from this book, but I have to find out if I have the permission to put it on the website, to post it on the website. I'll find out about that, because I know that if you purchase this book, a teacher can make a copy for their school, but I'll find out if I can post it. And then there is another book called Multicultural Mathematics. It's out of print, and George Joseph has said that we can share this with other teachers, but I just want to make sure, because it's a whole book, and all this will be put up on the website. So here are some useful links. This Mathigon timeline is very good, and I've used it. This is on the Mathigon website, and it's quite nice to use with students. Now, how do I go back to the thing? Okay, go to that. Sorry, is that in presentation mode? Nearly there. And then this is Maths History, St. Andrews University, lots of resources there. Students can find biographies. Story of Mathematics is another one. The next one is, these are the books, there is the references that I'll be sharing with you. You count in Greek, learning activities, multicultural mathematics, all of these are fantastic books. And also using history to teach maths. And the NCTM from America had their own website for that, historical modules. And I want to show you what I found recently at the Cohere Teacher Center. It's an amazing resource. This is Year 9 Maths Puzzle Books. And it's got, based on Maori, and there's book 1 and 2, and based on Maori legends and traditions, it's got a little bit about that information at the top, and then it's got an activity where you find answers and associated with a letter, and you know more about that Maori legend or tradition, and you find out the name of that. Amazing resource. If you haven't seen it, you can use it, and it's useful for years 7 and 8 as well. And it's very priced. It's only about $10 or $12, and I found that it was really good. And it's mainly it's on all topics in Year 9, and there is a tradition or Maori legend that's associated in the different pages. So I'll stop with that. I'm conscious that we have to stop in a little while. And thank you so much for listening. And yeah, I can take some questions and comments now.
Okay, well, thank you very much, Marla, for a very interesting talk. I know I spoke to an Italian maths educator not so long ago, and he was telling me about history is very explicit in the Italian maths curriculum, and it's features in all their textbooks, and is a big feature of all their activities. So that's another culture which really embraces the importance of learning the history of mathematics as part of your knowledge of mathematics. That I was interested to see you use that Florence Nightingale diagram, because I listened to a Cautionary Tale podcast. It's called, the podcast called Cautionary Tales, and actually says how Florence Nightingale exploited how to lie with statistical graphics by using that graph to get what she wanted, which was better hygiene standards in the army hospitals. So it's a very interesting podcast event. I put a reference in the chat. Now, in the chat, there were some requests for all the resources, the books that you were holding up. So hopefully everyone's noted that they were given in the slides, and these slides will be available on the website. It might take a few days to get everything uploaded to the website, but they will all be available. So you'll see all those links on Marla's slides. But if anyone's got a question, they can pop it in the chat line. I think the one on the book on that you mentioned at the end there about the Maori problems, Marla, they were really so several other people in the Zoom have used them with great success. So they were a very good tip.
Yeah, that's great. Yeah, I found it and I used it. It was really very useful, which is, I thought some people may not know about it, and that's why I thought I would share it. But it's great, and it'll be good to find out from people how they used it, and you know, how they structured their lesson around it as well. That'll be good, because there are cross-curricular opportunities here as well. And it's interesting what you said about Florence Nightingale. So she lied about that, but all for a good cause.
All for a good cause, yeah.
All for a good cause, yeah. But it was interesting when I searched for, you know, resources for statistics. I came across this, and I thought, with the pandemic on, there was someone who's done some work like this, and it's interesting that she's used polar diagrams, and you know, that's not something that we usually use with students, and it's an interesting alternative. Yeah.
So there's lots of comments coming in thanking you for a very interesting presentation, Marla. Okay. But and thanking you for giving them lots of ideas of things that people can use in their classes. So, but I haven't spotted any actual questions for you to answer.
That's okay. Yeah.
So we'll just leave the chat open for a few more minutes. And but if you've got no questions, feel free to leave. But remember, there are some other exciting sessions coming up at 11. So we've got Jared Hockley, What is Doing the Maths, Tech or Learner? We've got Jeanette Chapman on the Learning Progression Frameworks, which everyone should know about. And Pip Arnold on Ideas for a Matariki themed lessons. So that's going to be very topical and something that you can use shortly in your classrooms. So feel free to go and grab a coffee and put your feet up for the next session starting at 11.
Thank you. Thanks, everyone.
So I think We can stay on a minute, Marla, if you like. If we'll stay on till 1:45 and we'll close it at 1:45. So keep sending your questions in. If you've got any questions you want to ask Marla, pop them in the chat line.
Yeah, what you were mentioning about that Italian maths educator is very interesting. I would like to find out more about how they are using history in their classroom, and what levels, what is the kind of activities they give their middle school especially. And yeah, it'll be very interesting it'll be really interesting to talk to. It'll be great to read a paper where they're just given how they are using history in Italian curriculum. Yeah.
There was another guy at Auckland who worked for Clear. He's not there anymore now, and I'm struggling to remember his name. But the aspect of history of mathematics he was interested in was historical mathematical instruments. So early counting machines and sort of machines, instruments to measure angles and lengths and things like that. And he actually had quite a vast personal collection of all of these historical mathematical instruments. So that's a sort of another aspect of mathematical history that's quite interesting.